I am Olmo. I am a colleague from Mike. I also work at Karakun. Quick introduction on the company too. We are based on Basel. We are a general software company, develop custom solutions to very wide type of customers. And to facilitate that, we have several platforms, and one of them is Hibu platform for NLP processing. It's a platform where, among other stuff, we do information extraction and data analysis on a very wide type of documents, and all the analysis is based on content. We developed the solution to be deployable as a software as a service, but also on-premise, on small workstation or even laptops running offline with no access to internet. And one of the core point of information extraction is, as you know, garbage in, garbage out. So we need to provide good content, especially when we're working with scans. So OCR must provide reliable content with less noise as possible and as close to the reality as possible. So about OCR, usually to get good results, you require time and/or resources. Most of the time, you require both of them. The best solutions requires a lot of effort, a lot of beefy hardwares with GPUs, or it's not self-hostable. You have to rely on third-party providers. And this is actually a limitation for us because most of the time we work with self-hostable solutions, open source software, because, as I said, we deploy it also in laptops where we don't have GPUs, and the RAM is quite limited, so we cannot run whatever we want. And for that reason, we did some exploration, we did some experiments on different approaches you could follow to get a good, I will not say a great result, well, it's a great result, but to get as close as possible to the best tools available. The ultimate goal is always to perform information extraction, so we don't need to be perfect, we need to be good enough. For this case, for what I will present today, we don't care about the text coordinates, we just care about the extracted text, so the plain text in that case. We can see a couple of documents. Those are my documents, so the owner doesn't complain that I show it to the public. And sorry, it's in Italian. My mother language is Italian, but I guess it's not a problem for a conference based on the language. Here we can see that we have some bad scans with a recipe on top of an invoice. We have contracts with signatures and handwritten content. Or we can see other scans. I'm pretty bad using my scanner. But we also have some clean print text with, I would say, complex layout, but not linear. We have a region on the left that it's not related to the main content in the center. Or we have invoices, quite old invoices with bad quality overall. So we started exploring different approaches. We started from the most traditional way, using major framework like Tesseract. Then we tried to move to most modern frameworks, what we called neural OCR, with Easy OCR, Pedal OCR, or DocTR. Then some language models, visual language models. My favorite one, Olmo OCR, great model. GLM OCR and Falcon OCR, and many others. And then at the end, we tried to combine those three different approaches together to mitigate some of the weakness. Let's start with the first one. I think everyone knows Tesseract. Great advantage is that it has a minimal memory footprint, can run in basically any workstation. It's really competitive when you have clean printed text. With handwritten text, you can get better results with other tools. And also, it fails from time to time when you have structured layout, when you have tables, maybe complex tables, and so on. Metrics are great. Processing speed on my laptop was quite good, 2 seconds per page. With some more complex page, it goes up to 14 seconds, but those were edge cases. Where it failed, for example, we have this document. For the purpose of information extraction, we want to extract the place and the date where it was signed, and who signed the contract. We sent the document to Claude, for example, and we got a nice result with the layout that it was basically as it was in the scanner. When we run it against Tesseract, it fails. The name is completely wrong, just forgot the B, the name is not readable, we don't have the date anymore. So these results, it's basically useless in this case. So we had to try something better, hopefully. And we went with the neural OCR approach. Those tools, most of the time, uses a two-stage deep learning pipelines with some deep learning models, neural networks, and so on, where they first do text detection, and then based on where the text was detected, we do text recognition. Those tools are ready to use. You don't have to train anything. You don't have to do anything. Just plug and play, send a document, and you get results back. So it's very easy to use. They're usually trained on multilingual data sets, so also for Italian it's perfectly fine. Based on our test on my laptop, DocTR, document text recognition, was the fastest pipeline. That surprised me a little bit, to be honest. It had a good accuracy, also with handwritten text. It uses more memory compared to Tesseract, but it's also faster. And from time to time, it also failed on layout detection with complex documents. We can see here, for example, we have this invoice with the headers and what my brother bought here. And Claude extracted it perfectly with the layout, very great. DocTR failed miserably. You cannot understand what's the prices, what's the VAT, how many quantities, and so on. It's more difficult to extract, to understand. So information extraction here would fail. Consider that we are always running on resource-limited hardware. So also for information extraction, we have to run with maybe rule-based approaches. We cannot rely on big LLMs that might overcome these issues. Next step will be vision language models. This is a little bit of a stretch because to get good results, good inference, you usually need either a server or a GPU. Just wanted to add it as a comparison. There are some smaller models that works quite good, but they are more prone to hallucination and not following instructions properly. So it adds another complexity on top of that. But the good thing is that if you have a multimodal model, you can reuse it for information extraction or for whatever. It's not tailored only to vision, to OCR. So maybe you can save a little bit of resources in other tasks of your platform. I used Olmo OCR. I'm very fond of this model, maybe because of the name. The good thing about this vision language model is that they understand the document structure and the semantic of the text all in one step. So they might correct some noises on the scan or something that it's not clear with the language knowledge they have. The bad thing is that they require hardware. I tried to run it on CPU only, 3 minutes per page on average. That was, even for us, it's unusable. With the GPU on my laptop was better, but still quite slow with 40 seconds per page and used a lot of RAM of the GPUs. And the output also, that's a big problem for us, is that it's not deterministic. For example, in my system prompt, I asked to really extract tables with either markdown formatting or plain text. And as you can see, it's HTML tags, which could still be okay, but yeah, didn't follow the instruction I gave it. So could be a little bit of a problem for us. And also is more prone to other hallucinations, but I don't have an example for that. And the last step we tried is to combine the previous approaches. One of them is to use a small language model that can run on CPU with decent speed to correct the results from another framework, like a faster framework like Tesseract or DocTR. This will add a little bit of latency on top because you're running two tools, one after the other. So it might take more time, but still you could solve a little bit of issues. It has the good thing is that can correct the noise, correct the issues at sentence level, not just a single character, but really understand if at the sentence level there is some issues, maybe the order is not correct or something like that. But as I said, it increased the processing time, and those small language models, they're very prone to hallucination and not following instructions. I had some troubles working with them because there was one model that kept running into loops, and instead of extracting one table, it extracted like 25 tables, all duplicated. And this add on top of being already quite slow, add more time to the processing. The resources used, it's not that bad, about maximum 6 gigabytes of VRAM. So that's doable on consumer laptop if you have a GPU. If you don't have a GPU, then it's getting way too slow, and then it's probably not usable if you have to process a lot of documents. We can see here, I realized this morning on the train that that's actually not a great example, but one thing that it corrected, it's that Tesseract extracted the printed text very well, as we have seen before, but it really followed the lines that we have in the document. And here, the phone number is split in 2 lines. And if we're using a rule-based approach, regular expressions, and so on, to extract information from the document, for example, the phone number, in this case, it could be easily fail. While the small language model correction actually realized that it's the same sentence, put it in a single line, and now we have the full phone number. Yeah, here, sorry. Full phone number here. I realized that it's not a great example because you could do that just checking if the line ends with a dot or not, and then merge with the next line. It would be a 3-line of codes. But still give an example of the kind of correction that you can do with a small language model. Another approach, a hybrid approach, is to put on, before doing the OCR, put a layout detection model. There are some small models from Pedal OCR or Doc Layout YOLO. It's 50 to 200 megabytes, can easily run on CPU. You detect the region of the document. That's very useful, especially if you have 2 columns or complex tables where Tesseract or DocTR easily fails. You can put that on top and then take region per region and send only the specific region to Tesseract, and then reconstruct the text based on the order that you sent it and the order you get back from the layout detection. Unfortunately, I thought that it was running out of time, so I didn't add the results for that. Really sorry, I was way faster than I expected. And to summarize, overall, in our experience, there is no best approach at all. It really depends on use case, how many documents you have to process per day or at a time, on the resources you have, what's the expected results. Maybe you can rely on having a little more noise because information extraction is easy because all the documents look the same or stuff like that. Really depends on the use case you have and what also the client expects, the customer expects. Latency is not always so important. We have cases where we can process documents today and give the results back to the customer in 3 days. So in that case, even processing a page in 3 minutes will be okay, will not be a big issue. What we've seen that combining the different approaches, if you can afford it, will really help to mitigate all the weaknesses of the different pipelines, of the different tools. And you can really play around and do a lot of stuff and customize it as you wish, depending on the documents you have and what's the expected outcome. What we also realized that small language models, either vision language models or small language models, they can be very helpful, but you have to be very careful working with them because they're very prone to hallucinations, to not following instructions. can give you a lot of troubles. You will need to test it truly, maybe with Mike's framework. That could be very helpful. So it's helpful, but you need to be very, very careful about that.